today we're going to be doing transformations of quadratic functions. And notice that chapter 2, it's 2.1 says quadratic. We're dealing with quadratics all this chapter. Okay? To help us review about transformations that we did last chapter, I want you to complete 1 to 3 here. Okay? You can work with your groupies, but complete 1 to 3. We're going to apply those translations and those transformations to linear and absolute value functions. So number 1, translation 3 units right. So today I'm going to be referencing again inside or outside. And remember, if something happens to the inside, that means when I'm writing it as g of x equals f of x, this piece right here is the inside. And remember, when something goes on the inside, which way are we shifting? Vertically or horizontally? Horizontally. So when I say a translation of 3 units to the right, is that a vertical or a horizontal? Horizontal. So that happens inside. And when I'm going to the right, am I adding or subtracting? Subtracting. Now, many of you did this on your test, and some of you got it right, some of you got it wrong. Those who got partial credit were the ones that could write this out. If you're not writing it out in this form, it makes it a lot more difficult when the problems get more difficult. Question?
What if we do that but forget to put in the f? So we did g of x equals parentheses x minus 3.
Then that wouldn't be right. Okay? So the next piece would be to take this and plug it in for x right there. So I now have g of x is equal to, I drop the f, and I plug in the x minus 3 for x. And then I have the plus 6 back here. And we don't want to leave it like that. We want to combine like terms. So we write it as g of x is equal to, can't do anything outside of the parentheses or bring anything into the parentheses. So we just, negative 3 and 6 is positive 3, x plus 3. Now remember, linear equations, kind of the vertical and horizontal shifts kind of end up gelling together once you get it to slope-intercept form. Okay, so. All right, number 2. By the way, how many got that one? Okay. For those of you who didn't use this format, it makes it easier as you progress, right? We do the easier problems in that so that when you get to the more complex one, you know how to do that. Okay, so it's like if you think back to multiplication, you started out with like 2 times 1. You're like, woohoo! I know that's 2. Okay, we didn't start you with like 22 times 493. Though some of you are probably trying to work that out. Do it in your head. That's okay. Don't get focused on that. Okay, that's not what we're focused on. All right, so this one, translation left, which way? Or, excuse me, add or subtract? We add, and are we inside or outside? Inside. So now, when you think of going left, you think subtraction, but remember when you're dealing with the inside, it's kind of opposite. So when we're going 3 units left, we're actually adding 3. So g of x is equal to f of x plus 3 this time. Okay, and this part, again, goes in right there. So we get g of x is equal to it's plus 1, not 3 units. Thank you. Unbelievable. That's why everyone was saying plus 1. I'm like, the answer's not plus 1. What are you talking about? Thank you. Okay, so that should be a 1 there. And then we add 3, or subtract 3 to that. So we end up with g of x equals x plus minus 2. All right. How many got that one? Hopefully you did better than I did. Good job. All right, translation, 1 down. Inside or outside? Outside. So we have g of x is equal to f of x, and it happens outside, so we are going plus or minus 1? Minus 1. Okay? And so from that piece, this is my g of x, or excuse me, my f of x is this part right here. That's what f of x equals. So we plug that in for f of x. Let's make that minus 1 on there. Okay, so that gives me g of x is equal to this whole chunk, absolute value of 5x minus 2, all minus 3. And then we have the minus 1. Okay, can't do anything inside those parentheses, so, or excuse me, you can't bring anything into those parentheses distributive-wise. So we go ahead and take that. We take -3 and -1 to make -4. How many got that one? Okay. Now, those should be fairly easy. Okay, today we're going to get a little more complex. What I asked you to do kind of in preparation for this, I asked you to complete this page. This was page 24 of your student journal. So if you look at that, let's go ahead and go through those answers just really quick. Okay, so go ahead and find that. Or letter A. Letter A went with graph D. Letter B went with graph C. Letter C went with graph A. Function D went with graph F. Function E went with graph B. And function F went with graph E. Now, tell your neighbor how you came up with those. Like what strategies did you use?
Well, I looked at the negatives. You can see if it's like going to the right.
All right. Help me out. What are some strategies you came up with? Like, what were some ways you came up to narrow these down? Chase.
I looked at it had like a negative in front of it, like that means it's upside down.
How many did that? You look for the negative sign to see if they're upside down. Good. So that, like for A, that narrows it down to A for function A, to graph A, to graph E, or graph D. Okay. How do we narrow it from that? Emma? Okay, so you went a different route. You found the vertex first. Okay. Okay?
So H is the line of symmetry, so I use that to find the vertex. And HK is the vertex.
Okay. Good. Sarah?
You can look at the end to see if it's going to be going left or right.
Okay. So if we're looking at the H, let's stay focused. We'll go with the H, whether it's going left or right. So in this one, we go -2, meaning we're going to the right 2 units. Okay. So upside down ones, that one does not go to the right 2. That one does, and that one does not. So automatically is letter D. The only one that could work. If I look at another negative shift, so for instance C, it looks like it goes, that's a +2, so that one goes to the left 2. This one goes to the left 2, as does this one. They're both upside down because of the negative. However, this also shifts down 2, which is A. Okay, so we go left and then down. Okay? So once we, like you guys are talking about, I like the axis of symmetry, that's your H term. Okay? Once we figure that out, then we have to also look at our vertical shift as well. Okay, and then you can think about width. That's a wider because it's closer to 0, and that one's narrower because it's further from 0. How many got all those correct? Okay, did you check them on your calculator? Okay, let's take a look on number 2. Go ahead and turn the page there. Number 2, quick summary of our info that we had for last chapter. Notice we're dealing with quadratic here now. So g of x is equal a times the quantity x minus h quantity squared plus k, where a is it determines our width. The further from 0, the narrower the graph. It also determines whether it opens up or down. A is negative, opens down. H shift shifts the graph right if it's negative, left if it's positive, and k shift shifts it up or down. Now technically when I say if it's negative, I mean if you look in here and you see a minus h. Right? Bless you. So that's what I mean when I say if it's negative. Okay. Any questions there? So that graph right there, tell your neighbor what you got for a solution. All right, that's what I got. Okay. How many got it? Yeah, right. Okay, so did anyone put an A term in there? Kind of hard to tell. I mean, but It looks like it crosses there. Good, yeah. So if you really look at this, it appears as though it goes from your vertex over 1 and then up 1. And that would be your A term. You can always figure your A term like that. It's a good point. It's kind of tougher to tell because it doesn't have a grid, but if you really like zoom in. Oh, dude. Hold on, let's try it again. It doesn't want to focus all that well, but it looks like it's a 1, over 1 and up 1. All right. Check out my hand. That's huge. Okay. All right. We are going to move on to 2.1, page 26 of our student journal. I got to really zoom out. It takes a long time here. All right. Page 26 of student journal. So, some of you guys did your test. You saw your test scores and you're like, holy cow, I have never in my life got a score like that. I mean, an A++++. No, some of you didn't do as well as you wanted, and some of you did better than you thought, but keep this in mind. If you're struggling, if you didn't do well with it, we need to figure out where your disconnect is in terms of preparing for the test. And we'll talk about how we're going to resolve all that later. But one way to help prepare for the test is right here. We don't define these things right now, but to help yourself review, later on you can go back to your student journal and check these out. Try to define them. Write down everything you have. It's a quick review. Looking at your core concepts. Okay? So remember these pages when you're preparing for your test and quiz. They're good pages to review and maybe quickly go through and try those vocab terms. So some core concepts. Horizontal translations. I'm pretty sure you guys are pretty good with this, but when we shift left or right, happens inside, it's your H term. Remember, if H is negative or if it says minus H, you're shifting to the right. It says plus H. Where's my plus H? Oh, I don't have H. It says plus H, I'm going this way. Now notice it says shifts left when H is less than 0. Let's think about that for a minute. When H is less than 0, it says it shifts to the left. Give me a number that's less than 0. Okay, does everyone see the problem there? We say when it's negative up here, we shift to the right. Okay, but they're saying when H is less than 0, we shift to the left when it's negative. Okay, so let me explain what they're talking about there. That says, think of it this way. If I put, let's say this is negative 3 right here. Yeah, the formula says x minus h. Very good. So that would be x minus negative 3, which is actually positive 3. Okay? That's why. So when you start seeing the math behind it, the wording, you're like, oh man, that's a... Okay? Whereas this would be, if it was positive 3, we'd say x minus 3. I like to think of it this way. Whatever makes that 0 is where it shifts to. Okay? So what makes this 0? 3. That's where I shift to. What makes this 0? Negative 3. That's where I shift. Okay? I didn't want to make something that seems so easy become very difficult, but that's the wording behind it. Questions there? Okay, let's summarize the vertical shifts. They're more straightforward. If it's greater than 0, it shifts, it's less than 0, it shifts down. Greater than 0, it shifts up. It happens on the outside. All right, so I'm losing people because this is just so boring, so let's go to the more complex stuff. Here we go. That'll make it more fun. Page 27. Reflections in the x-axis. If we reflect in the x-axis, remember when we reflect in the x-axis, the values that are actually changing are y values. Your x values don't change. So whatever was right here, the point stays right there on the x-axis. However, it changes on the y-axis. Therefore, it is a vertical change, which means it happens on the outside of your f of x. Whereas when I reflect in the y-axis, okay, what was right here now goes to right there. Okay, it is a horizontal change. Nothing changes vertically. When you change horizontally, it's on the inside. It's f of negative x. Okay, that may not have been a big surprise to some of you, so some of you may still be bored. But any questions there? Josh? No? No, you're just like rating it as a 5. Your mind blown? Okay. Okay, horizontal stretches and shrinks. This is when we get to be really, really fun. It's a hoot, if you think of it this way. Okay, a horizontal stretch and a shrink. If you are stretching something horizontally, you are pulling it away from the y-axis. So if I am pulling this parabola, here's my parent function. If I am pulling that parabola away from the y-axis, it's getting pulled this way. It's like I'm taking it and pulling it downward towards the x-axis. I'm stretching it horizontally. If I am shrinking it horizontally, I'm pushing it together towards the y-axis. I'm pinching it towards the y-axis. Yes?
Isn't a vertical stretch the same as a horizontal stretch?
Okay, hold on. Ask that question here in a minute. Okay? So, when I'm dealing with a horizontal stretch, the kind of difficult piece is right here. A horizontal stretch away from the y-axis is actually between the numbers 0 and 1. It exists. So most of you go, yeah, it's a fraction. Well, it's a fraction that's between 0 and 1. Because technically 5/3 is a fraction too, but that's bigger than 1. It's like a proper fraction. It's proper. Yes, it's a proper fraction. Okay? It is a fraction. And a horizontal shrink is actually a number bigger than 1. So when you start thinking of terms, you're like, hold on, I stretch, doesn't that mean it makes it longer? Shouldn't that number be bigger? Well, here you're dealing with a number less than 1. And when I shrink, doesn't that mean it goes smaller? Shouldn't that be smaller? No. Remember, everything that happens on the inside is kind of counterintuitive. Okay? So when I say I have a horizontal stretch of 1/3, okay, or better yet, I should write it like this. When I say I have f of 1/3 x, that actually means I have a stretch of 3. Okay? When I have f of 1/3 x, that's a stretch of 3. We good on that? When I have f of 2x, that means I have a shrink of what? Shrink of 1/2. It's a reciprocal of that. Okay, it's backwards from what you would think. So that's why when we say, well, your stretch is actually less than 1. Well, it is when you put it in there, but when you express it, it's greater than 1. And your shrink is actually bigger than 1. Well, that's what it is when you put it in there. However, your A term is, but when you express it, we express it as less than 1. Okay? And we're going to see that in the first problem we do together today. Okay? Vertical stretches. Kai, we're almost to your question. Vertical stretches and shrinks. Vertical goes, if you're stretching away from x. If you're shrinking towards x. It happens on the outside, so now your A term's on the outside of your f of x. And it's just like you would think. If you stretch, A is bigger than 1. So if that number's bigger, you're getting further away. If you're shrinking, it's between 0 and 1. It's smaller. It's getting closer to. Okay? So Kai's question is, go ahead, Kai. Wouldn't a horizontal shrink be the same as a vertical stretch? It can be. However, the values would change in terms of what we express for A in quadratics. And it depends what's inside with the x. And we're going to see that on the first problem we do as well. It's a good question. Yeah, we'll see that here in a minute. Okay? Any other questions there? All right. So here's what we're going to do. It's actually not the first problem. We'll see it on. It's on the fourth problem. I'm sorry, but we're going to do some basic ones first. Okay. This is monitoring progress. This is, remember, out of your textbook. Okay. I want you to describe the function or the transformation of the function, and then graph it. So you've got grids on your graph page or on your note page. So go for it. You're going to try number 1 and try number 2. I think we'll probably be good with those, but if we need to, we'll do 3. All right, to help complete number 1, I am going to graph the parent function first. And the vertex of the parent function y equals x squared is at 0, 0. Then 1, 1, and then 2, 4, and then 3, 9. And then reflect those points. Okay, those values I just graphed, for those of you that are doing quadratics and you're not familiar with that pattern, keep in mind if the a term is 1, you just go over 1 and up 1. Over 2 and up 2 squared, which is 4. Over 3 from the vertex and up 3 squared, which is 9. And so your 4 would be over 4 from the vertex and up 4 squared, which is 16. Now if a is a number other than 1, you just multiply by that a term. As we're going to see, that's your vertical stretch. Okay, you're taking the number you're inputting and squaring it and then stretching it by that value. Okay, so in this case, we're not stretching though. We're actually shifting where? Shifting right. By 3 units. Okay, so each of those values that you have on here have to move over 3 units. Okay. There's our graph. Just taking that parabola and sliding it over 3. So this would be the graph of y equals x minus 3 quantity squared. Okay. Questions on it? Just put it in the inbox. Okay, number 2. What's our shift? What's this shift do? Shift right 2. Okay? And how about this? Down 2. Okay? Are they dependent on each other? Are you shifting on the same axis? No. So are they dependent on each other? No. They're independent of each other. Okay? This shift will not depend upon that shift. So as I shift to the right 2, so remember my vertex of my parabola would be right there. If I am shifting it to the right 2 units, there goes there, and then I shift down 2. I end up right there. Or I could shift down 2 and then right 2. I still end up in the same spot. So that's my new point. Okay? Maybe I should use those different colors here. Let's see. Just circle that one in red. Okay? Then my next point is over 1 up 1. Well, that would be the next, let me put my parent function on here. Okay. All right, there's my parent function. So my shift here, I shift all those over 2 and down 2. Over 2 and down 2. Hit something under my paper there. Okay, you get your parabola. How many think you got that? Okay. Any questions on that? Okay. Then let's try some more of the complex stuff here. All right. Number 4. Describe the transformation of f of x equals x squared represented by g, then graph the function. So in number 4, tell your neighbor what the transformation is.
Number 4, you can do vertical stretch of one.
All right, let's wrap up discussion. Okay, so I heard some talk about vertical stretch, horizontal stretch, some horizontal, I couldn't tell if it was shrink or, okay. I've got my parent function down there, my y equals x squared again. Is this a vertical or horizontal stretch as it's written? Or excuse me, is it vertical or horizontal as it's written? It is horizontal. Okay, it's inside, which means it's working on the horizontal. Okay, is 1/3 a stretch or a shrink? That is a stretch of what? It's a stretch of 3. It's a horizontal stretch of 3 units. Okay, so what that means, now here's conceptually where I'm hoping that we'll pick this up. Okay, what that means conceptually is that each of these points is being stretched 3 times the distance from the y-axis. So that means since this point currently is on the y-axis, my vertex, it's not going to move. It's like moving 0 times 3, which is 0. It doesn't move. This one is how far away from y? How far is this point from y?
1.
It's 1 unit. So when I stretch it by 3, I have to multiply that by 3, which means it will now be 3 units. 1, 2, 3 away. Okay, so I'm stretching it 3 units. If this is 2 units from the y-axis, I'm stretching it 3 times 2, which is 6. 2, 4, and 6. Okay, and this point is how far from y? 3, which means I am going to stretch it 3 times 3, or 9. Notice my parabola is getting wider. And then we've got the same thing on this side. Okay. Raise your hands if you think you got it. Any questions there? Okay, now I want to go to Kai's question. Kai said, isn't a vertical or a horizontal stretch the same as a vertical shrink? Or vice versa, right? And the answer is, yeah, kind of. Okay, so like this right now, to get this 1/3 out of the parentheses to make it vertical, what do I have to do to it? Come on, mathematically, what do? We square it, right? Like square x, you get x squared, and square 1/3, you get 1/9. Okay, 1/9 x squared. Now you have a vertical. What does that mean? Well, that means this now is a vertical. Vertical what? This is a vertical shrink of 1/9. Now the best place I can show this on our current graph is right here. This is our original point. If I shrink that towards the x-axis by 1/9, I'm at 9. 1/9 of 9 is 1. It brings me to right there, which is the exact same point as that. 1/9 of this point is right here. And if you start going, well, what about those other points? Well, 1/9 of this point is like way, way close to the x-axis. 1/9 of that point is way, way close, like on the x-axis almost. It's at 1/9, right? If I shrink this one, well, that's 4. 4 times 1/9 is 4 1/9 is 4/9. 4/9 is just like what number? 4/9 is really close to 1/2. You guys are killing me here. Okay, 1/2 and 1/2. All right? Notice how you start getting this cheesy looking grin down here. That happens to be the bottom of your parabola. Okay? Just so we're aware, a horizontal stretch of 3 is the same thing as a vertical shrink of 1/9. So are they the same? You can get the same place, but they're not the same numbers, right? So you just can't use the same 1/3. Other things happen to it.
But if there's another factor, like what if it was 1/3 x minus 3?
Then you got other stuff you have to worry about.
It's not the same.
Correct. You got to deal with other stuff. Okay, I want you to look at numbers 5 and 6. Actually, look at 5. Tell your neighbor what's going to happen with that.
It's gonna be that.
All right. Hey, what's going to happen on that one?
Vertical stretch of 3.
Good. Vertical stretch of 3 and? Good. Horizontal translation or slide or to the right 1 unit. Do they depend on each other? One's going vertically, the other one's going horizontally. Do they depend on each other? No, they can act independently from each other. So if we take each point right now and do a vertical stretch of 3, here's my parent function. If I move each point a vertical stretch of 3 and then 1 to the right, that might be a little easier. So like if I stretch from 0, I'm stretching vertically, right? So I'm stretching away from the x-axis. If I'm at 0 and I multiply by 3, I'm still at 0. But then I have to move it over 1 unit. Here I'm 1 unit from the x-axis. If I stretch it by 3, I have to multiply it by 1 times 3 is 3, which means now I'm 3 units away and move it over 1. This point, how far away from the x-axis am I? At 4. So 4 times 3 is what? 12, which means I'm off my graph. Okay, and then I have to move it over 1 unit. So that's right there. That would be at the coordinate 2, 12. So if you go off your graph, make sure you label your coordinate there. So that point, and that point is one side of my parabola. Notice that graph got a lot narrower. Okay, and then we'd have to reflect those points. So we'd be there, and then we'd be up here at negative 112. Okay, our parabola went on a diet, dude. Got skinny. Okay, how many think you got it? Okay, here's what I want you to do tonight. I want you to take your, go ahead and look at your student journal. And in your student journal on page 28 is the extra practice. I want you to do your best to complete the extra practice. Okay? Do your best to complete it. We'll continue from there tomorrow.